Thank you for your patience. Now we will move on to our next session, Utilization of Nuclear Energy. And I'd like to introduce our moderators and speakers for this session. For our moderators, Mr. Tanaka Nobuo, Chair, ICEF Steering Committee, former Executive Director, International Energy Agency, CEO, Tanaka Global Incorporated, Japan. Professor Sally M. Benson, ICEF Steering Committee, Professor, Energy Science and Engineering, Stanford University, Deputy Director for Energy and Chief Strategist for the Energy Transition, White House Office of Science and Technology Policy, United States of America. And for our speakers, Ms. Caroline DeWitte, co-founder, Oklo Incorporated, United States of America. Mr. Matt Wilkinson, CEO, Thorcon International, United States of America. Dr. MORIWAKI Masanao, Senior Vice President and General Manager, Global Business Development and Management Division, Hitachi GE Vernova Nuclear Energy Limited, Japan. Mr. Lee Warren, Director, Engineering and Technology, Rolls-Royce, United Kingdom. Mr. KISHI Hisashi, Deputy Division CEO, Global Business Department, Chubu Electric Power Company Incorporated, Japan. And Mr. George Borovas, Head of Nuclear Practice, Hunton Andrews Kurth LLP, Managing Partner, Tokyo Office of Hunton Andrew Kurth LLP, Japan, United States of America. So now I would like to ask main moderator, Mr. Tanaka, to moderate this session. So Mr. Tanaka, please take the floor.
Thank you. This is the session which I like most, by the way. Well, because I know the nuclear is a very, very important area. I'm always promoting the new concept of sustainability model of the nuclear power. At the beginning of ICEF, nuclear was not picked up as a session. So I urge METI that we have to discuss about nuclear to make the sustainable or decarbonized world. So after a couple of non-nuclear ICEF, finally I succeeded to convince METI that we have to pick up nuclear issues in the ICEF meeting. So I really very happy to have a really good lineup of people for talking about the innovation in the nuclear power. I know Caroline DeWitte, when I visited New York with David at the Center on Global Energy Policy, discussing about the future of the nuclear at that time. And Caroline explained about Oklo. And Oklo is probably the most advanced nuclear technology which came from Idaho National Laboratory of pyroprocessing and sodium coolant fast reactor. And this is the first time it is going to be a commercial model. There are many different ideas for this concept, but Caroline, I think I congratulate you that you are already quite a big publicly owned company, even without producing any electricity yet. But I think, how do you think the future of Oklo and how you can contribute of this new business, a new technology and with new business model for the global community? Of course, but you are starting with the US, but I really wish that the success of Oklo will make a big difference in the future of small modular reactors. Please, Caroline, you have the floor.
Thank you so much, and thanks for having me. It's an honor to be able to speak with you all today. Yeah, I think the global demand for energy, and I'm sure this has been discussed many times already, so I won't bore with statistics, but it's just, growing astronomically, let alone domestically here in the United States where I am. So it seems to me that there is just no end of need for clean energy, and a rising tide lifts all boats in terms of the demand for nuclear power is great, and there are many players in this space. We have sought a model that, like you have mentioned, which is we basically provide electrons instead of neutrons, right? And so what we find is that customers want to buy power. They do not want to own and operate a nuclear power plant. And so we've really designed our whole business model as well as regulatory strategy around providing that product to customers that need it. And that required starting, I think, small and really strategically with our regulatory process, because we were acting essentially like a utility instead of just a nuclear design developer. And now with being public, as you mentioned, we have access to capital markets that really change the aperture for what's possible in terms of project financing, which is really essential for us to really start not just building one plant, but building many plants and developing out our project finance portfolio, essentially. We just announced, like you mentioned, a recycling facility in Tennessee here in the United States. And one thing that I can say both for the United States and for the globe is the existing used nuclear fuel, you might call it nuclear waste, could power, the amount that's in the United States could power the entire United States if powered only on that for 100 years. And similarly for the world, in terms of the world's capacity, to be powered by just nuclear waste for the next 100 years. So there is a ton of energy without even having to do mining, without even having to do enrichment. And I think that's still something that people are just starting to realize and hear the story. And so that's just, I think, tremendously exciting. And like I said, I think the market needs all the above. So all the other speakers, I think, have a very exciting story to tell as well. But that's kind of how we focused our energies and where we see the development happening.
Thank you, Caroline. I think the President Trump sometimes do very mischievous things, but for the nuclear, he is doing a really good job, because he released the 4 executive orders in May about facilitating the recycle of the spent fuel, right? And making the fuel security with using more plutonium. How do you evaluate? I talked with also Chris Wright, the energy secretary in some part, and I remember he is on the board of Oklo. So the US is definitely on board for developing this new type of nuclear technology. Do you agree with me?
I think, certainly right now there's so much happening, and it is tremendously exciting. And I think those executive orders really kicked off a whole new wave of what's possible. I can list about a bunch of different ways that has happened. I will in just a second. But I will say, too, that, I think we started our company back in 2013. And under, then President Obama, there's some, we went to the White House as part of this Advanced Nuclear Summit in 2015. And then under Trump 1, I think even more support happened. And then under Biden, it increased. And then I guess I'd say under Trump 2, it's only accelerated. So I think one of the great things, at least in the United States right now, and I worry about it getting too politicized, but I think it has been a very bipartisan issue where both the Democratic Party and the Republican Party have been pretty supportive of advanced nuclear in recent years. And I see that trend generally only continuing. But yeah, and to be clear, Chris Wright was on our board, and then when he was confirmed as the Secretary of Energy, he left our board, and we no longer have the ability to directly interact with him in the same way. But it has been really cool to see. I mean, he was an incredible person. That's why we loved having him on our board. But when we heard that he was potentially getting tapped for this position, we thought there's no one better. He knows energy inside and out. And I think they've really tried to make a lot of big changes in terms of changing how the regulatory paradigm is done. Like you said, opening up what's possible in fuel, for fuel recycling, plutonium, just examining all the different ways to deploy nuclear and do it faster than has been done before. Oklo in particular is participating, but a number of companies are participating in the reactor pilot program and the fuel pilot programs. And I think like that should enable construction to happen quickly. One of the goals is for several reactors in the United States to hit criticality by the sesquicentennial, so by July 4th of next year. And I think some will. And so I think that'll just be a really energizing moment for nuclear energy.
Thank you, Caroline. Let's move to Matt. I know that Thorcon is providing the, let's say, technologies of floating nuclear to Indonesia. And this Thorcon technology is certainly very interesting because of the, let's say, use of a new small modular reactors type and providing it with as a module. The cost could be much lower. The security could be treated differently than the large light water reactor. What do you think about the Thorcon's future and the success of the business model is really happening with your company?
Yeah, well, thank you. It's a pleasure to be here. It's nice to see Caroline again. Caroline and I first met about 10 years ago. We were, back then, Jacob and Caroline and I were all voices, lonely voices in the wilderness. And so things have really changed for us through perseverance. And I agree with Caroline that it takes, many flowers will bloom, and we need all of them. So it's great to see all the success that Oklo is having. Let me just say a few words about Thorcon, because there's not a lot known about us, and I think people speculate and kind of wonder what is Thorcon. So we're focused on nuclear that's safe, that's affordable, and that's fast. Today's nuclear is already very safe, but what's new is that the world is at a point where the engineering pathway to equally safe but much simpler and cost-effective designs are well understood. So there's elegant, inherently safe reactor designs in hand today. They're passively safe and capable of shutting down without operator intervention, thanks to the laws of physics, and dramatically reducing overheating risk. So what's happening is we're moving from safe, if perfectly operated, to safe by physics. And that shift opens the door to mass deployment. So that's key. Another key is is affordability. I think the world's next chapter of energy demand will be written by the developing world. That's where we got into this. That's what motivated us from the very beginning, and that's our focus. AI may double or triple energy use in places like the US and Europe, where the base is already high. In contrast, billions of people in the developing world are starting from a much lower baseline. And they're industrializing and urbanizing and electrifying on a historic scale. The absolute scale of new demand is much larger. Between now and 2050, most new electricity generation is going to come from countries where the grid is still expanding, places where the energy transition isn't about replacing old systems, but rather building them from scratch. This is the battleground of global energy demand, in my view. This is where the future of electricity will be decided. And these nations, they're not going to adopt nuclear because it's clean or because of its elegant engineering, but they'll adopt it if it's cheap. And if nuclear power can't beat coal on cost, it won't be adopted at scale, not in the places that matter most. And that brings me to the third key, which is speed. Even if we get the safety and the cost equations right, nuclear still fails if it can't move fast enough. We can't take 10 years to build a power plant anymore. We need to bring timelines way down to a couple of years. And that means designing for delivery and not just for operation. And we have to stop thinking about nuclear as a big civil construction project. And we have to start thinking about it as a manufactured product. And not just any kind of manufactured product. We have to leverage the most efficient, most sophisticated large-scale manufacturing system the world has ever built. And that's the modern shipyard. We got our start. Our founder is a guy named Jack Devaney. And Jack started his career as a tenured MIT professor of naval architecture. And later he moved on to design and build and operate several of the world's largest ships. And they're called ultra-large crude carriers. And these ships are huge. They're 380 meters long. Each one of the ships that Jack designed and built took a year to build and cost about $100 million back in the early 2000s. And these ships are roughly twice the size of our power plant. So right there, we can see it's possible to build big things very affordably. When Jack learned about the molten salt reactor that was developed at Oak Ridge in the 1960s, he realized its inherent low pressure made it possible to design a nuclear power plant for shipyard construction. So we're building a 500 megawatt nuclear power plant that's fully assembled in a shipyard, transported over the ocean to its destination, ballasted to the seabed just offshore, it's not floating, and then connected to the grid. And we can do that from start to finish in under 2 years. The thing is safe by design, it's radically affordable, it competes with coal on cost, it's rapidly deployable, and it's easy to scale. So I just wanted to say those few things just to kind of orient the group around, what is Thorcon? Well, that's it.
Thank you. Thank you very much, Matt. Yeah, you mentioned about the kind of advantage of the small modular reactors, safety issues, affordability, and build it in time in very short period of time, rather than the very long construction period, even sometimes extended than planned, and create a problem for the major energy players. I think let's move to the small modular reactor is certainly the very key elements for the future of the nuclear technology, that IEA said. But unfortunately, in Japan, the small modular reactor is not that popular. I think Moriwaki-san, Hitachi is certainly only company or maybe who are interested in small modular reactors, and they try to market it to not in Japan but in other countries. But how do you see the prospect of small modular reactors for the Japanese market or for your technology in the future?
Okay, thank you very much, Tanaka-san. Before asking your question, I'd like to introduce myself. My name is Masa Moriwaki. I'm a Senior Vice President and the General Manager of the overseas nuclear business. So my responsibility is not really in Japan, but overseas. And my current responsibility is leading a small modular reactor project under the partnership with our partner company, GE Vernova Hitachi Nuclear Energy in US. So two joint venture companies were created 1997, and aiming for synergy between two joint ventures, and also the bringing the latest cutting-edge technologies of the boiling water reactor technology to the customers all over the world. So in Japan side, Hitachi GE Vernova Nuclear Energy in Japan, we had accumulated the experience of the nuclear power plant design and also the construction. Construction. That differentiate us from the other, SMR vendor actually. And after 1990s, we started build advanced boiling water reactors, which is a 1350 megawatt large-scale reactor, latest boiling water design in operation. And we built them within the cost and within the schedule, on schedule. So that's we're proud of this track record. And but unfortunately, after Fukushima accident, our construction effort in Japan has been suspended. So that's a very difficult situation. But in the meanwhile, in the US side, GE Vernova, Hitachi started new effort on the SMR. And that was materialized as a joint development of the BWX300. And BWX300 is a 300 megawatt SMR. That's a 10th generation BW, that's why BWX. And that incorporates innovative passive safety features, which enable this reactor much more safer and also much more cost-effective than previous BW generation. For example, that when the severe accident happened, this reactor doesn't need any power, any the operator intervention for 7 days. So that's important lessons learned from the Fukushima accident. So in Canada, Ontario Power Generation, that selected the BWX300 as their SMR. And the OPG is a very experienced, nuclear operator, and they study a bunch of SMR, and finally they selected BWX300. And just a real construction has been started in the Darlington site, India site, in May. So real construction already started. And this is very significant for the nuclear industry because this is the first SMR construction in the Western world. So there's many stakeholders in nuclear industry watching this progress, very closely. So Hitachi, my company, Hitachi GE Vernova Nuclear Energy, play an important role for this project as well. We are providing engineering, and also we are supplying the critical nuclear components, export from Japan to that's Canada, and also we supporting the construction based on the Japanese experience. So the collaboration between the OPG in Canada, GE Vernova Hitachi in US, and Hitachi GE Vernova in Japan demonstrate the power of the international collaboration in the advancing the nuclear technology. So we are very happy to hear the interest of the SMR. It's rapidly growing in Japan as well as all over the world. And this is the right time to discuss, the SMR. And to your question about in Japan, unfortunately, yes. So that the Japanese customer, tend to prefer larger reactor because the site is very limited, and they would like to use maximum, site. So that, if they afford to have a bigger reactor, they would like to have, maximum size of the power. So that's one of the reasons. But there's some needs for the SMR. Those customers would like to increase the demand a small amount, one by one. Then that suits that's those customers. So I think there will be the possibility in Japan as well. But the first project will be Canada, and it is very important to make this Canada project successful. Otherwise, we see there's no future for the SMR if we fail in the first project. Thank you very much.
Thank you, Moriwaki-san. Yeah, and very candid view about what's happening in Japan. And certainly, the utility is very concerned about safety and replacement of the old reactors in their nuclear power plants, and certainly limitation of the siting is really urging the utilities to use the large type of the reactor. But for the sake, because I'm just curious, because large light water reactor, which Japan demonstrated the safety and quality, but it's very costly. after the Fukushima accident, the safety requirements for the Japanese reactor is so high, the cost of large light water reactor is enormously high. And that means if we build it in Japan, replacing old one, the cost of electricity is getting higher, right? And all of these costs will be passed through to the consumers or industry, and that hurt our competitiveness. So I'm rather prefer going to the small modular reactor, which is probably at the beginning costly, but eventually being reduced the cost, as predecessors saying, and may provide an innovation of the nuclear for the future, and which is also deployable to the other part of the world, just as you are doing in Canada. So I am a bit cautious about separating Japanese market and international market for the sake of competitiveness of nuclear industry of Japan. I'm worrying about it. How do you share this my concern, Moriwaki-san? Yeah.
So this is really tricky question, but I really, share your concern. Japan can be isolated because, that we are, Japan used to be a center of the nuclear industry. We have a lot of expertise, experience. But now that we are deviated some different direction from the mainstream of the, the nuclear in the world. So, I would like to really participate, Japan to the, global trend. Yeah. Thank you very much.
Thank you, Moriwaki-san. Very candid. I'm very much encouraged to move to the small modular reactors. Warren, I think you are from the Rolls-Royce. Rolls-Royce also doing SMR, but I think you're representing advanced modular reactor, which is high temperature gas coolant reactor, I guess. And how do you see that this new type of reactor business in Europe or in UK? I think are you getting more good success story? Because we need a really good success story to promote SMR. SMR has been discussed for years or decades, but none of them has been built except in China and Russia. So I just want to see the success of Rolls-Royce.
So do I, thank you. So first of all, Tanaka-san, thank you for inviting me to the panel today. And my colleagues in Rolls-Royce SMR are very busy making sure that an SMR is deployed quickly. But I'd like to talk for a few moments about advanced modular reactors. So we believe the market for advanced modular reactors is evolving rapidly, and it offers huge potential benefits for energy security, for civil and defence applications, and importantly for industrial carbonisation. And we believe that small AMRs can provide scalable, flexible, off-grid heat and power for commercial and industrial use. So when coupled with coated particle fuel technology and advanced modular manufacturing techniques, as we've heard earlier, we see a potential for a dramatic step change in the nuclear industry, delivering power directly to where it is needed by the customer rather than the traditional grid utility-based model. The scale of demand for secure, resilient and sustainable heat and power solutions has expanded much more rapidly than expected only 5 years ago, with a substantial opportunity emerging for small, scalable units with electrical and heat outputs of around 20 megawatts electric or 80 megawatts thermal. Rolls-Royce estimates the attainable global market, so not just Europe or not UK, but global market, to be approximately £400 billion between now and 2050, and we believe that represents a production of around 1,500 units. So to address this opportunity, over the last 5 years, Rolls-Royce has been quietly in the background focusing on technology development. We've selected high-temperature gas reactor and coated particle fuel technology, which we believe offers the best opportunity to address these market needs, whilst minimising waste and proliferation risk. So by prioritising technology maturation and drawing on the full breadth of Rolls-Royce's proven end-to-end engineering and manufacturing capability, we have identified AMR solutions that address scalability, industrialisation and supply chain needs to provide customer-focused power solutions. This is a unique differentiator for Rolls-Royce. It brings together our deep expertise in gas turbines in our aerospace business, with a long history of end-to-end naval reactor design and development in my part of the business. It will drive efficiencies through modular manufacturing techniques and high-volume factory line production, in contrast to some of the larger alternative technologies developed by others based on early concept design proposals. So we believe we can establish an AMR demonstrator by the end of the decade and deliver the first units to market by the early to mid-2030s. But to realise the full benefit of advanced nuclear technologies, we believe requires concerted, collective action by governments and by regulators to remove barriers to market access, streamline regulation, and avoid duplication across multiple jurisdictions. The UK and US agreement last month was a great example of how governments can work together to accelerate development of new nuclear technologies, as well as recognition of the high level of government and business interest in nuclear energy. Of course, it also requires establishment of a commercial HALEU fuel supply up to 20% enrichment, which will be a major constraint in the development of the industry through to the early 2030s. We at Rolls-Royce welcome the steps taken by governments to start up the HALEU supply chain and end reliance on Russian fuels, of course strengthening the Sapporo 5 agreement. The development of advanced nuclear technologies offers an opportunity for the UK and like-minded countries, such as Japan maybe, to remain at the forefront of global nuclear industry, establishing a leading position in fuel supply and strengthening international partnerships. We very strongly believe that AMRs and coated particle fuels represent a paradigm shift for the nuclear industry, moving from a utility-dominated, grid-connected model to a new, more flexible, dispersed model, providing power directly to customers where and when they need it. This will deliver increased energy security, support for energy-intensive industries and industrial carbonisation. It will also support business development and provide the energy needed to underpin our defence and civil security needs, laying the foundations for future security and prosperity. But building and maintaining public confidence will be essential to secure the social licence needed to underpin a new nuclear renaissance. Government, industry and regulators must focus on building public understanding and awareness of nuclear technology to create the conditions for success. Maybe this is the biggest challenge faced by our industry.
Yeah, Warren, I think a high-temperature gas reactor has had an interesting feature of passive safety, right? And it is tested already in JAEA facility in ORI as well as in China. So you think if you deploy your AMR in the UK, the kind of emergency planning zone could be 0 kilometers radius, that kind of different regulatory safety standard be expected for your reactor?
Very, very definitely. As we've heard, I think Matt mentioned, it's so important. Safety is paramount in our industry. I think we all know that. So the importance of passive safety and that walkaway capability is a fundamental requirement. It always has been with all of Rolls-Royce reactor designs. And as you say, Tanaka-san, fundamental that we reduce that emergency planning zone down as small as possible, which in turn will bring, hopefully, that public confidence in what we're doing. And I must add, having seen the HTTR experiments, I think what Japan's done is absolutely fantastic.
Do you think public acceptance substantially increased with this feature? I mean, are you successfully making the public acceptance exercise or communication?
I genuinely hope so, but as I've just said, I do think that we must continue as industry with governments and regulators to work together on that and to continue to drive that public support.
Thank you. Well, let's move to the KISHI-san of Chubu Electric. Because Chubu Electric, I invited him because Chubu Electric invested in the new scale, the small modular light water reactor. I think I never see any Japanese utilities interested in a small modular reactor except Chubu. So I'm just wonder, is this safety requirements, a passive safety feature or to limit the emergency planning zone as small as possible, that kind of safety feature is the reason for your interest in the small modular reactor, or just why you are interested in the small modular reactor? That is my question to you, Kishi-san.
Yes, thank you, Tanaka-san. First of all, thank you for inviting me to this wonderful and important session. Actually, yeah, as Tanaka-san said that Chubu Electric Power is one of the minority shareholder of the NuScale, the US developer of the SMR module. Precisely that in 2023, we entered into an agreement with JBIC to acquire certain interest in NuScale, together with JGC, IHI, and JBIC. Actually, that for all your question, our investment in NuScale that represents a strategic initiative to ensure the access to a diverse portfolio of technology that support the long-term sustainable utilization of the nuclear power. The Chubu Electric Power is actually a retail company, and then the sale around 100 terawatt-hour of power annually. Roughly, this is around 10% of the total energy sold in Japan. So therefore that we have that kind of a duty and the important role in supplying electricity on the basis of the energy security and the economic efficiency and the environment and the safety. We call this 3E plus S. We would like to reinforce our commitment to 3E plus S with the possible solution of the SMR. Actually, I would like to emphasize also that it is unchanged that the restart of the Hamaoka nuclear power plant is the most important for us. In near term, this is near term. And at the same time, in longer term, it is important to continue to promote the social implementation of the innovative technology for 3E plus S using the SMR. Yes, thank you.
Do you see the feature of passive safety, but is one thing, but also do you see that the building construction period for SMR could be much shorter? I mean, as Matt explained, that it should be less than, not as long as 10 years, it should be much shorter. So this kind of short period construction certainly is one of the attractive points of SMR for you. Or I have also heard that the number of operators for SMR could be much smaller than the large-scale reactor, and that's another feature of the attraction of the SMR. Is that true?
Yeah, thank you for the question. Actually, firstly, as Tanaka-san mentioned, that the SMR is small enough for the factory fabrication and easy transport. And installation schedule is more predictable and also the cost effective. So that's why that this could avoid the cost and the schedule overrun. And then the next is the operator issue that I'm not sure that the detail, but according to for the information of the NuScale, that E2 center, actually, it will dramatically decrease the number of operators because the design is very much simple. So that's why, yeah, I heard about it.
Thank you very much. Let's move to George. I think we have discussed once about the potential of AI usage in Asia, and maybe SMR could be an interesting model to supply that kind of business chance. And also, I have a question to you because you are the legal expert, and certainly the issue of nuclear is very much of the legal nature sometimes. And do you think that President Trump's executive order in May pave the way for further use of the nuclear in the United States or in other part of the world? That is my question to you.
Sure. Thank you very much, Tanaka-san. You always have very interesting questions. I hope my answer is just as interesting. But first of all, on the issue of AI and the data centers, this has been an ongoing discussion in the past, I would say, 2 to 3 years. The major data center developers, the hyperscalers, the Amazon, Googles, Metas, Microsofts, they have all started being very interested in nuclear. Some of them had invested in nuclear technology companies. They're planning on it. I think what happens with the data center companies is that they realize that nuclear provides the solution to their ambitious plans to develop AI in data centers around the world. It's clean, it's 24/7, it's reliable. So the data center companies are certainly going to become very important for the small modular reactors and all the technologies that you see here in front of you. And I think that what's going to be really important about them is that they're going to be able to provide a couple of things. First of all, very important from a project financing point of view is knowing how much power you're going to sell at what price. Liberalized markets are very difficult for nuclear, even small modular reactors. So having a power purchase agreement with a data center company is going to be very important, because you can just say for the next 20, 30 years, we're going to be sending power at this price. I do think that we're going to have to go one step further beyond that, especially for the first of a kind. The first of a kind for a lot of these nuclear reactors is difficult, right? Because as you see in front of you, the companies are private. They're privately owned companies. They can take certain types of risks, but they're not the state-owned enterprises that we see in places like Russia and China. So the structure has to be done in a way that's going to be supporting these, especially for the first of the kind, so we can have the deployment. And after you have the first, second, third unit, after that I have full confidence that these technologies are going to be able to be built in series. You will have an established supply chain, you will have the models down, you will have the operations down. So I think it takes a lot of that effort and the data center companies can help provide a little bit of that project structure. We're doing this, we're actually actively negotiating now in the United States these kinds of arrangements between a US utility, a technology provider, and an off-taker, a data center. So I see that these models are developing as we speak. To your second question, Tanaka-san, the executive orders from the Trump administration, I think it's a huge change. I want to reiterate something that Caroline said before, is that this has been an amazing transformation of the politics in the United States. Nuclear for a long time, especially since 3 Mile Island, had what I call bipartisan indifference. It was not Democrat versus Republican. Both parties were pretty much indifferent to nuclear. They did not really support. Now you have Trump administration, the first Trump administration, really being very supportive. The Biden administration, again supportive. Trump's second administration, fully supportive, again even more. And every time we see an acceleration. And that is a huge win for the nuclear industry. Because as anybody that follows US politics knows that the country is basically divided on every subject. Nuclear seems to be the one subject where there is that bipartisan consensus. So looking at the regulatory side, looking at the fuel side, the fuel cycle, the supply chain, helping the government supporting the development of these demonstration reactors is going to provide a new ecosystem in America to kind of regain its capacity to deliver nuclear projects. Let me stop there.
Oh, thank you very much, George, explaining about what's happening, and also especially the megatech firms interested in the data center of the kind of dedicated power for these companies. In the executive order, the Trump administration's interest is more kind of fuel security, supply security, increasing it by using the plutonium from the spent fuel that reduce the dependency of enrichment to Russia. That's a basic motive. But do you think this cycle technology can substantially reduce the waste, radioactive waste, and toxicity of that. So does it help to make nuclear more acceptable to the public?
I think personally, I think it does. We have to be a little bit careful because, of course, there's the non-proliferation concerns that come with the recycling, and that needs to be addressed. Japan, of course, is fully immersed in that dialogue. And the way that you help with that is, of course, with information, people understanding exactly what it is that you're talking about. Why is recycling important? The amount of energy that's included in the so-called waste is tremendous, as Caroline told us before, quantitatively, how impressive that is. But I do think that takes a lot of international collaboration, understanding, and we're looking at making sure that everybody, all the issues being addressed in terms of the issue about waste, because there's huge advantages, but again, we have to be really careful with the message that comes out in the issue of proliferation.
Yeah, thank you. Caroline, I think we have talked about this special feature of Oklo, which uses spent fuel as a fuel and plutonium use, and also reducing the waste toxicity. Do you think the Oklo technology is getting this kind of sales point to the public, or do you use this as an important feature for your business success in the future? This waste management is definitely one of the very substantial issues in Japan. After accident in Fukushima, how to take care of the meltdown debris is a really, really challenging subject for us. So this take care of the waste is a big image and issues in Japan, and Oklo will provide the solution for that. So I'm really curious, how do you see these radioactive waste issues in your technology?
Yeah. There's kind of a lot of questions embedded in that, Tanaka-san. Thank you for that question. I think I'd echo the prior speaker, but one thing that I think is one of those things that we need to help carry a message about is that there's different types of recycling and reprocessing, and I think all of them are safe and can be done, very well, and have been done globally very well. For instance, France does a lot of reprocessing and recycling of their fuel, etc. I think in the United States, people have presumed that it's not economically feasible to recycle versus produce fresh fuel, but that paradigm is really driven by an expectation of recycling large water-cooled reactor fuel, or just water-cooled reactor fuel, recycling it for use in other water-cooled reactors. And what we're looking at doing is actually taking conventional water-cooled reactor fuel, the existing waste that exists in the country today, and recycling it for use in fast reactors. And one of the things that makes that quite different is you don't actually have to extract plutonium or other isotopes of concern for proliferation purposes. So when you don't have to extract that, you don't actually see that kind of stream that comes out of a waste fuel that people are worried about. Where does it go after that? We don't even isolate it. We utilize basically the whole waste form in a sense, minus some fission products, and recycle that. It's a proven process. It's just not been done much because fast reactors aren't commercialized, so there really isn't a demand for it. And it's something we've always had our eyes on, and we've literally been working with DOE to use recycled fuel for our very first Corla. We're literally working with DOE right now on recycled fuel material. So it's not something that would happen at some big point in the future. Literally, our first reactor will operate on recycled fuel. But then, in the meantime, we'll need some other fuel sources, I think, before we actually get a large-scale recycling facility up and running, which we are also working with DOE on multiple different projects to commercialize this kind of long-standing recycling technology that hasn't really been scaled up to the commercial scale. So I think there's a lot of promise there. I think one of the things that I think people within the nuclear industry have always thought is, you can't bring this up, the public won't understand it, there's all these proliferation concerns. And what I've seen over and over again is like, people are like, man, when this really comes out, people are gonna be really worried. And what I see is the average person in the public, or even people from all across the spectrum, political spectrum, or kind of views on nuclear power, they're like, wow, you can use nuclear waste and use it as fuel. That's a good thing. So on average, I don't see the concerns that I think that historical nuclear industry has been worried about. And I think that's very exciting. It does show that you can make use of this waste that already produces a lot of energy. It's already very energy dense, and then it can produce even more energy. And I think that's really exciting. Like I said, there's so much energy left in it. It's almost disingenuous to imply that we could utilize all of it. But it is a way to make use of waste in a very productive way.
Okay, thank you very much. Also, I think Idaho National Laboratory's integral fast reactor is kind of nuclear proliferation resistance. That is another feature of sustainability of the nuclear power. So it's the Oklo's model is also satisfying this kind of, let's say, feature?
Yeah, there's inherent proliferation resistance as well. Things like it being very hot, both in temperature and in terms of radiation. It's also called self-protecting.
The minor actinide is among the, let's say, in the same fuel that prevent the use of plutonium for the bomb. That's a kind of interesting argument about this technology. By the way, let's move to Moriwaki-san. I think Hitachi GE has the similar commercial model of Idaho called PRISM. Are you seriously thinking of deploying or developing PRISM in Hitachi GE?
Yes, PRISM is a fast breeder reactor with metal fuel, and this is for the future. So this is a kind of design for the future market in the time of the generation 4. But we believe at this moment, next decades, probably the light water reactor-based SMR or large reactor will, that's work. And after that, generation 4 reactors come. So we should be ready for this. And we are working with the GE Vernova Hitachi, which developed the PRISM reactor. Now that design was shifted to the TerraPower. It's called Natrium. And Natrium have a demonstration, the project in Wyoming right now. So they are going to start construction, actually. But in Japan, this PRISM type reactor for us is a really Japanese market in the future. And the first reactor will come to Japan, that's much more later. That's our belief. So that's we are working. Yeah.
Thank you very much, because I think this PRISM or Oklo, the similar type, can be applied to the debris, meltdown debris solution. Because we have to take care of debris in Fukushima. It cannot be transported out of Fukushima to anywhere else. So it should be treated there, and separating from the debris, the plutonium or minor actinide can be burned in a small fast reactor and reduce toxicity and stored in somewhere in Fukushima. That kind of solution, we need this technology of Oklo or PRISM. That's the reason why I'm saying this is a very, very important element for the solution in the Fukushima. And we, Japan, Korea is interested in this technology. That's the reason why I invited Dr. Wong here, because Korea, Japan, and US can develop the solution for Fukushima. That is the very important element for the public acceptance of the nuclear here. By the way, let's move to Matt. This floating nuclear is another very important element. So do you think there are many different ideas of floating say technology? Are there good collaboration among different players about the future of the floating nuclear power?
Well, just to be clear, our power plant, while we float it from the shipyard where we build it to its destination, we ballast it down to the seabed just offshore and it's a gravity-based system. So we are not floating. Now, it is true that a whole lot more of the world opens up to us if we are floating. There are seismic constraints that make it difficult to be, where you have to be careful about where you place your plant. There are many places in the world where we can go right away with the plant we've designed, but we can enlarge our market and go to places where you're offshore and you're floating, and the tsunami risk is substantially mitigated. And that is definitely an area that we intend to pursue. There are people that are encouraging us to pursue it sooner rather than later. And there are good reasons for that and good reasons against it. So we have to be focused. But when you've got a power plant that's sitting offshore and you have the right kind of semi-submersed rig that it sits on, you can mitigate nearly all of the motion of the sea, which if it goes unmitigated, you may have issues with your cooling, and you may also have issues just in operating your turbine. If your turbine tolerances are too narrow or too small, and you get a big wave, you may have a blade fly off into the rest of your factory, which would be a bad thing. So, yes, there's definitely a need to pursue this. There are challenges to overcome. I don't think that they're insurmountable. You may have a slightly less efficient power plant than one that's ballasted down to the seabed, but it's definitely doable. I do worry about how getting this approved through the existing maritime regulations. They're very strict. It took decades to come to an agreement on certain ship-based rules. And so trying to get a nuclear power plant through those same regulatory bodies may prove challenging. There are also pretty significant security topics that come up. You need to be prepared to somehow mitigate a potential terrorist ship strike. Yeah. That you barrel a ship directly into your power plant is a difficult security issue. So we're choosing now to stay focused on our existing design, and eventually we will invest some time in looking at that because it enlarges our market.
Right. Thank you very much. Japan tried the vessel with nuclear power some time ago. We made a small mistake and it's aborted. But certainly the floating is one way to make a light water reactor passive safe, because if some accident happens, just sink it, then we can stop it. So passive safety of the light water reactor is on the ocean or in the ocean like submarine. But Warren, for the Rolls-Royce, do you think to deploy your reactors, the public acceptance is very important? Do you have, this communication issue is key element for success of small modular reactors or advanced reactors, whatever the new. Do you, what kind of effort you are doing for this convincing public, the accepting the new technology?
So my colleagues in Rolls-Royce SMR have been very busy with that, not just from a Rolls-Royce communications perspective, but again working with the governments that we intend to operate in the countries of, and also with the regulatory community. Really important, I think we've heard about 3 Mile Island, you've mentioned Fukushima. Incidentally, the British Embassy yesterday, there were some excellent exchanges between the UK Nuclear Decommissioning Authority and the JAIF. So some really good work being done between the UK and Japan on decommissioning safely. But I think there's more to do. There is always more to do. We also rely quite heavily on the fact that, from a nuclear perspective, Rolls-Royce has operated, designed and supported with the Royal Navy in the United Kingdom for 60 years, reactors in naval submarines very successfully and very safely.
Okay.
That's something important for us to build on.
Kishi-san, the same question to you. How we can promote the small reactors in Japan? I mean, probably communication with the public is very important. So do you think the Chubu is engaging that kind of exercise?
Yeah, thank you, Tanaka-san. Yeah, actually, that in Japan, that as we all know, that the security issues are very much important. The safety remains our highest priority, and yeah, based on the no more Fukushima accident, that we are committed to doing everything possible to ensure the safe use of nuclear energy. So that's why the safety is a top priority. And about the public acceptance, yeah, this safety is very much important. So the demonstrating the proven safety and technology that along with achieving that economic viability through the widespread deployment in for example, the United States could help the build the support, the public acceptance in Japan for SMR.
Yeah. Thank you. Borovas-san, what's your view about this issue of communication?
I think it's extremely important, but also I think there's a lot of value that the nuclear industry can get out of the engagement with the public. What we have seen in a number of countries deploying new nuclear is that once people understand and they understand what's happening, what are the issues, what are the challenges, what are the risks, they become much more supportive of nuclear. I have personal experience with this. You know, you go to a party and somebody says, well, what do you do? Well, I'm a nuclear energy lawyer. My first reaction sometimes like, oh, that's too dangerous. We shouldn't be doing this. Once you start explaining in simple terms and plain language, people are stunned, because they just have a completely different impression. You know, I always use this example. Most people around the world believe that nuclear fuel waste looks like what they see in The Simpsons. This gooey plastic, green thing. So engaging with the public and speaking not down to them, but in plain language is really important to support these projects.
Thank you. Is there Dr. Wong of Korean Hydro and Nuclear Power in the floor?
Right there. Right here.
Oh, yes. Dr. Wong, could you make one comment? Because you are the representing nuclear power in Korea. And I always urge the Japan-Korea collaboration on nuclear. You were in the session before. But how do you find, how do you see the SMRs in the other part of the world, and how do you respond?
Yes. Until last month, I continued contacting with SMR developers in the world. And actually, KHNP has been developing its own SMR, LWR type. And we are finishing design. We are going to finish standard design by the end of next year. And beginning 2027, we are going to apply for licensing, which will take 2 years. And we are going to our construction will begin as early as 2029. And actually, in Korean government's electricity demand and supply plan, according to it, this year, we are going to receive an application from local community, which we will want SMR. Yeah. And today, I learned very much about SMR, updated informations. And Thorcon about molten salt reactor, I introduced in Korea 2012. but it took almost 6 years until Korea Atomic Energy Research Institute began their development. They are in the way of developing molten salt reactor. Anyway, GE Hitachi, we really expect GE Hitachi's BWRX succeed in OPG at Darlington, because that signals the opening of SMR markets. Although there are more than 100 types of reactors under development, there will be less than 20 or 10 models will survive. Back in early 20th century, there were more than 200 automakers in the United States. But in several decades, only 3 or 4 survived. But SMR's case will be different, because SMRs, third generation SMRs can provide electricity and heat at very low temperature. But as you go up to SFR and HTGR, the heat temperature goes higher. As temperature goes higher, this type of SMRs may find different application in the industry. So various types of SMRs will survive. And about the public acceptance, KHMP approached this way. We developed SMR-based smart natural city model and persuaded local community, Daegu, city of Daegu. That city was planning to build a new airport surrounded by a new city, of which the population was planned to be 200,000, including industrial areas and transportational areas, things like that. And that city needed net zero. So we developed a model based on SMR, together with about 20 or 30% of renewables, that we could reduce. We showed them we could reduce energy cost by 30%. Actually, local communities, they worry about losing population. They all lose population, and they lose. They don't have any attraction points for industries to come. Yeah? So, if the local community can provide using distributed energy systems like this, reducing 30% of reduced energy cost, then industries surely will come. Yeah.
Thank you very much. Well, I will finally give the floor to Sally Benson, because I think for the nuclear, the importance of women's opinion is key elements, because I created in Cannon Institute the working group only consisting of women except me, and discuss about what is the necessary condition of sustainability for the nuclear power. It's because women is much more concerned and very sensitive about the risk and accidents or mistakes. I talked with one lady who created the security advising company in Japan, and she told me that she stopped recommending Tokyo Electric just half year before that accident. And I just wonder why you did so. She said, the company accumulated all the mistakes or failures of the company they recommend. And Tokyo Electric repeatedly do the same mistake and didn't change the system. That's the reason why she stopped recommending. And that reminds, and she said, why other companies didn't do that? Just I came to know that, maybe it's because you are the only women company. My wife remembers all of my mistakes since our marriage and reminds me from time to time. So women's view is very important for facilitating nuclear. If the president of Tokyo Electric were a woman in 2011, she could have avoided that accident. Hey, Sally, what is your view about and summary of our discussion?
Okay, thank you, Tanaka-san. With that, I'm not sure quite what I should say, but I think we've heard from our fantastic panelists here that we're poised for a new generation of nuclear power with lower capital costs, standardization, so it's easier to manufacture and license, safer designs and fuels, modular so that you can gradually build out the amount of power you need, much faster to deploy. Okay, these are all great things. I think by 2030, 3 or 4 of these new reactors will either be operational or very close to operational, so we'll have our proof of concept, which is fantastic. Nevertheless, there are very, very large challenges ahead. We've heard about first-of-a-kind cost. We've heard about supply chains for new fuels. It was very interesting to hear the Oklo example that wouldn't require a completely new supply chain for fuels. We have finance for new technologies that are riskier. Public support appears to be growing, but it's certainly not assured. And we still have the very serious issue of what do we do in the end of the day with nuclear wastes produced from these. So you know, the glass is half full, I would say. But I want to go back, Tanaka-san, to your point of the 1.5 degrees C. So we are at 1.5 degrees C, so one of our goals appears to be slipping from our fingers. If we look to 2 degrees C in the future, you know, certainly we need to strive our very best to achieve this. By 2050, we need to be at net zero. If we're going to be able to limit warming to the levels that we think will avoid tipping points. So this gives us a very short time frame. Say we get our first reactors by 2030, by 2050, we need to be at net zero. So if we think historically about many other technologies, energy technologies in particular, the time that it's taken to go from from proof of concept to 1% market penetration, 1%, not a lot, has typically been on the order of 20 to 70 years, okay? We obviously don't have time for that. So if this technology is going to really make a difference in the climate issue and security issue, we need to do something very, very differently than we've done in the past. So we really need to think about making this a top priority, not changing, you know, every 4 years or every 10 years or whatever. We need to stick to it. We need collaboration and cooperation. The government needs to work with the private sector to support the development of this technology. We need buyers clubs where like-minded companies can get together and commit to a common design and perhaps sharing the costs of the first 10 units, for example, that will mitigate the risk of a first-of-a-kind deployment. We need to work on international technology transfer and diffusion, and we need to also take advantage of those high potential early markets like data centers where there are people with a demand for clean power now and with the balance sheets to be able to support the development of this industry quickly. So thank you very much.
Thank you, Sari. It's very good summary. And I'm sorry that for the sake of, I like this subject so much, so I didn't manage very well of the time of this session. So forgive me of eating up some of your lunchtime, but I really appreciate all the good participants and panelists and have a very interesting discussion. Thank you very much.
Thank you, Mr. Tanaka, Professor Benson, and all the speakers. So I would like to ask all the people in the stage to stand up. We would like to send them with a big round of applause. Thank you very much for the insightful session.